This is a lesson on concept basics. First thing we're going to talk about is dimensional analysis. Dimensional analysis is sort of a neat way of converting from one type of number to another. You use that by using unit fractions and multiplying. So if you have 5,000 seconds and you want to change that to minutes, you want to get rid of the seconds, so seconds goes on the bottom, minutes goes on the top. And what's bigger, 1 minute or 1 second? 1 minute's bigger, 60 seconds, and then you proceed to divide. And your answer, seconds cancels, the answer is minutes. And so this also tells you that 5,000 divided by 60, whatever that is, will give you the number of minutes. You could also go, if you have 50 grams of oxygen gas, and use that to convert to liters. First, you got to get rid of the grams, which would be 16 grams, and that's 1 mole. This is a great view from last year. And then you have moles. Grams cancel. You don't want moles, you want liters. So liters goes there, and moles go there. 1 mole, 22.4. Moles cancel, so that leaves you with liters. So you initially start with grams, now you're in liters, and so now that tells you that you divide by 16 and multiply by 22.4. The next couple of sections are not much. The only thing that you really need to know is convert from temperature. Kelvin is equal to degrees Celsius plus 273.15. Absolute value is 273.15, negative 273.15 Celsius, so absolute value is 0 Kelvin. So you just plug the numbers in and go for it. Next thing is density, which is more of an application from the last lesson, significant figures and manipulating equations. Density is mass divided by volume. The mass is in grams in chemistry, and the volume is in cubic centimeters. So if you know 2 of the 3, plug them in and solve. A helpful hint, if you have a density of 2 grams per cubic centimeter and a mass of 40 grams, what's the volume? A neat trick is to switch the volume into 2. If it's like cross multiplying, and it doesn't matter which way you multiply, so you just switch the V and the 2, and you get 20 cubic centimeters. So that's the only really neat trick that you need to know on that one. So that's density. The last part is a whole bunch of definitions. Matter is something that has mass and inertia. Atoms make up matter. A whole bunch of stuff with the Higgs boson and stuff nowadays. That's cool. If you want to know more about that, talk to Mr. Kretz. Mr. Wentz. States of matter. Solid, liquid, gas, and plasma, being the hot gas that you're talking about there. Mixtures. Mixtures are a combo of substances with no set percentage. This is a functional definition and it works very well. Mixtures can be 1%, 5%, 15%, 50%, 99%. This next stuff is homogeneous. Homogeneous, homo means same, so it's the same throughout. So a homogeneous mixture is the same throughout. The example would be like Kool-Aid, thoroughly mixed Kool-Aid, so it's the same throughout, top to bottom, left and right. Heterogeneous. Hetero means different, which means you can see different parts of the mixture. Sandy water, water with some sand in it is a common example. Chocolate chip cookies, a food thing, you can see the chocolate chips. A solution. A solution is a liquid or flowing homogeneous mixture. Solutions can be thought of mostly as liquids. Sometimes you think of them as gases. Aqueous solutions deal with water. They don't have to be made up of water as part of stuff. A pure substance. A pure substance has 100% of the same composition throughout. It's not a mixture. 100% same throughout. On an atomic scale, if you go from one section to another, it's all the same. Compound is a combination of two or more atoms with a constant percent. So that's a variation between a mixture and a compound. Compounds are made up of two or more different types of atoms with a constant percentage, not 100. That would be a pure substance. Element is a substance made up of only one type of atom. Pure gold, pure oxygen gas, things like that. Chemical change. The chemical change is a process where new chemicals are made, new compounds, chemicals are produced. It's new stuff it's not the same as before. There's a different, if you look at the bonding way, atomic bonds are broken and reformed. So that would be a chemical change. A physical change no new compounds are made. Examples, distillation. Distillation is where a purification process where you heat up a solution or a mixture, and because different things have different boiling points, the things that will evaporate or boil off faster comes off first. You can separate things that way. Filtration is a purification process where you pour things through some sort of a catching, and the solids, generally separating the solid from a liquid, the solids stay behind and the liquids fall through. You got air filters, which has the solids remain and the air flows through. Chromatography is another way of separating things, and this is a diagnostic tool. You can identify how many, what types of substances you have in your solution by using chromatography. This ends that lesson on chemical processes.